Okay, so we left off, got everything deployed. I've updated packages. We're at like SvelteKit 1.9 something now. Anyway, one of the things that I really wanted to address is being able to create a custom SPL token that I can use specifically for my my app. And I have been going into another rabbit hole, learning how to do this. We learned how to persist a token, doing by generating a keygen, a new keygen and a JSON file, and then generating a key pair out of that JSON file, and essentially being able to create a new mint using that key pair. And that's all good. And I even, I had probably hour and a half of video recorded, gone through a lot, and here I'm showing you what I did is I created a new state account, defined here with a couple of new instructions I'll go over briefly, but yeah, all of this essentially to later realize there's a much easier way than what I came up with. And big shout out to the Anchor Discord as usual. We got Fedoris and Bear. Those guys are really just amazing. Big time shout out to these guys. They're constantly supporting everyone with questions. And friendly shout out to Soul this, along with the Anchor Discord, kind of led me to a much easier solution. So I'll get to it. So first, yeah, I created a whole new state account called a dApp token manager, and I may extend on this someday in the future, but we'll see. But yeah, I was trying to figure out, like, okay, I need an account. I'll create a PDA, and its sole responsibility is basically storing my mint and maybe having, keeping track of how many mints have been, how many users have been, have we worked, minted supply to, et cetera, even have here's a dApp token manager, create the dApp token manager instruction. Did all this stuff, have a validation struct, and yeah, like, this was working. I've had tests for it too. I did, like I said, had a good almost couple hours worth of stuff. This is the ledger, but then also to mint supply using the dApp token manager essentially, and this all worked. It's totally, like, looking good. I learned about init-if-needed and things like that, and I'm going to cover this in more detail, but long story short, this is all pretty much for nothing because there's just a much easier way to do. It depends on what you're trying to do, but for my sake, I genuinely just want to be able to create a custom token for my app, and let it kind of mint supply to a user whenever they create, say, every time they create like a new ledger, rather than generating a totally different mint each time like currently is doing. Instead, want to be able to have a single dApp token that can be minted, say, every time they create a new ledger. So that's kind of where we're going. But where was I? Yeah, so Soul Andy, along with some helpful clarification on Anchor, basically led me to this Soul Dev course. This thing is awesome. Shout out to James and the people behind the scenes that make this course. This is an incredible resource. If you haven't found it, I would highly, highly recommend. I have not gone through it, but currently Solana is working through it. And yeah, so check that out. But in this course, and I started to see some examples, but in this course they have Solana has a whole thing about cross-program invocation, CPI. And I actually know how to do it. I've done it quite a few times, and we do it especially with working with like the token program. We use a CPI sign with signer right here to MintTo Supply. And we've done that also for token transfers. So this all uses this concept of cross-program invocation. So certainly check that out. But the dev course has shows some stuff on how to use CPI in Anchor, which is nice. Essentially, you can pull in some dependencies, and you're pulling in basically another program, and you're just calling instructions, calling an instruction in that program. Just like here, if I go, where's my list? If I were to look in my cargo, yeah, let's do Anchor.toml. I'll go back to this. Oops. Just like here, yeah, for example, my ledger program, I am pulling in the Anchor Lang crate and the Anchor SPL crate. I believe that's the right phrasing. But you can essentially do the same thing. You can pull in another program of your own. Maybe it doesn't have a crate, but maybe you have it with you, in your code base. And anyway, this allows you to do, use its instructions from another program. And the point that really hit home is that, did you know that you can create, you can use the same PDA for a mint? So I know this may not see, but note that we can use the same PDA for both the address of the mint and mint account and the mint authority. Using a PDA as the mint authority enables our program to sign for the minting of tokens. Now, I know that a PDA can sign as a mint authority because that's exactly what I had done with this dApp token manager. I had made it a PDA, and then I had assigned it as the authority to my mint, so that the dApp token manager PDA account could sign. And it all works, not too shabby. But what I did not know is that you can actually use the same PDA for both the mint and its authority. So that is what we're going to do instead. So what that does for me is that I don't have to come up with a whole new state account, like a dApp token manager, for example. And my instructions really just to initialize a dApp token or dApp mint. It just simplifies it a whole lot. And what's great about this approach is that you, and I'll be copying this code basically, you can essentially init your new mint account all inside of your program. So you no longer have to, I don't have to deal with key pair files or I don't have to generate a new key pair and then initialize that as a mint and all that stuff. Instead, I just do it all right here inside of the program. and it's done. It's done. It's so easy that you don't have, like, you have a Mint account, which is what you're creating, but then its actual instruction function literally has nothing to, there's no logic to do, because everything is already taken care of inside of the Anchor macro attributes, like using init and seeds and all this. It's all configured in your validation struct for you. So then when you invoke this helper the handler function, it's it. There's no other logic to really do. So yeah, I was just about to release a whole continuing this whole bit, but I just maybe I will in a separate kind of series. I have some ideas about this. I think it could be fun to explore, but it's certainly a much more robust kind of approach than what really is necessary. So that is that. All right, so what I'm going to do, I'm going to leave these files as they are. So I have a state account called dApp Token Manager. I don't need it. But what I am going to do is I'm going to create a new instruction file. And what I'm going to call this is, I'm just going to call it, I could follow this. Initialize. No, I'll keep with the create. So I'll do create dApp token mint. Okay. Just name it something a little bit different than initialize token mint. We'll just change it up, but create dApp token mint. Okay. And what it's going to need, a couple of these. So I'm going to go ahead and copy that. But here, let's do it. So we have, this is just going to be another instruction for us, and with that, there's I need the validation struct, and I need the helper, or instruction function, right? That's kind of at the high level of what we're doing. So if I do pub function, and I'll call this create dApp token mint, it's going to accept the context, and we're going to call this just exactly it, create dApp token mint. So yeah, this approach just, it seems really clean, because I honestly don't have to do any handling of key pair files and whatnot locally, and being a PDA, we can do all the signing for future minting of supply and stuff. So yeah, let's see, do a message. Yeah, token mint created. And then as a validation struct, this is what we're dealing with. So, and to save some time, I'll go ahead and copy this over. I'm going to change a couple of things. Oh, I guess I copied all of it. Let's see. 8. Yeah. So what I'm going to do instead is I'm going to, rather than mint, so this is it. This is the key right here. By passing a seed, something like mint, or I'm going to call this dApp.tokenMint. That's it. It's going to use this. Payer, we can call it user. I may call it authority. Doesn't really matter. This is a one-time wallet payer, one-time thing, because after you create and initialize the token mint, then it's done. You don't. Also, being a PDA, it's already derived, so you can't. It's unique. You're gonna have these seeds with its bump. But what's crazy cool is that what's important about all this is that a PDA can be used for both. So what that means for us is I can, right here, you're setting these different constraints right here. This is, thank you, Anchor. Here we are. We get to build and initialize our mint right here. And when you do mint authority, we're setting the mint authority to the address. Like, we're passing in basically the address that was going to be used as this mint account authority. Well, using mint is the same thing, but this is going to be a PDA. This whole mint right here, it's going to be a type PDA, but what's really happening is we're getting a program derived address that we get using this seed as well as this program ID. So my ledger program plus the program ID plus this seed, a PDA address is going to be derived from that. So we have this, a pub key of some sort. And then we're going to initialize a mint account at that address. And so this is a really efficient way of using a PDA and enabling things like this. So I don't need like a key pair or whatever to sign and allow for minting of new supply or transfers and such. Everything is managed by this mint PDA. So that is super handy. So then the usual accounts that we would need to do something like this. So this is really like all you would need to do. We need someone to pay for this transaction. We need the token program because it's going to, it's part of like owning the mint, the token. We need the system program to do the whole initializing of the mint. It's got to create an account and all that stuff, but this is it. Really not much to it. And then here, using the instruction function, there is nothing really left to do. Again, it's just purely done for us thanks to Anchor. So next, I'm getting some complaints. Module tree. Okay, so let's go here. So I've added, because I've got in my instructions, I have a mod.rs file to keep track of all the modules that I'm creating. I'm going to move it up here, and we'll call this CreateDappTokenMint. And then same down here, pub use. going to bring all of that in. Can't find type mint. Okay. Any other things that we're missing? Token. Tokens used. What's not being used? Self is not being used. Guess I could clean that up a little bit. System program. Maybe you don't need that. Oh, yeah, and this is not really being used. This context, even though I have all these accounts that are going to be a part of the instruction, I'm not doing anything with them necessarily. So you can do the little underscore in front, and that kind of just Rust convention to say, okay, we don't really need, this isn't really going to be used. Now, what's kind of cool about this, and one thing else to know, Anchor.toml features seeds equal true. Basically tells Anchor to infer accounts for us. So there's more to it, and let me pull up a better explanation. Essentially, what you have is when you set this this feature. Let me pull this up, and it's going to be in your Anchor.toml file. You have this seeds false, and if I change it to true, with it false like this, then what I would need to do from the client, so when we start building up the usual, when you start doing from the TypeScript side of things, when you do, await program.methods, and then you would do CreateDappTokenMint. Normally we would do .accounts and open that up, and we pass in all of these accounts. So in this case, mint authority, there's things that we would have to pass. But if you have seeds equals true, and you rebuild, obviously I'd have to rebuild all this stuff by changing this with this feature. But then if you have like a PDA with its bump and seeds and whatnot, and it was all kind of created and initialized inside Anchor using Anchor, then Anchor can kind of automatically derive that PDA using with this feature. So, like when you have only a PDA, that's really kind of like the main account to pass to this. So like if in this case, like I need my mint, mint and whatever, like that's what I've got to pass from the client. Everything else can be like, it's a PDA. Anchor can find it and derive it for us because it knows the seeds. I'm telling it right here, like it knows this stuff from the validation struct. And all these other ones like authority is the wallet, token program, rent, system program. All those things are kind of like standard stuff that Anchor will automatically kind of include for you. So then it just means that from the client side, like again, you don't have to really specify the accounts because it can be auto-derived in this case. So you could do something just like methods.CreateDappTokenMint.rpc and you're good to go. So that's kind of like something that I have learned about as well. So with this done, we now have the makings of a really simple instruction to create a dApp specific, program specific token. Yeah. My next thing that I need to do is obviously need to be able to supply, like mint new supply. And to do that, I am going to open up my existing Mint. This is again when I was thinking about using a dApp token manager state account, but not necessary. Instead, yeah, I'm gonna change this up. Yeah, we're just gonna change this up. I've learned a lot from this, and I have it saved elsewhere. But what we're gonna do is just start over, okay? And the validation struct. Well, no, we won't start over. Let's just say I don't need a dApp token manager. I am calling this MintDappTokenSupply, so we'll use the same validation struct there. But this is going to be quite a bit different. One of the things that is to be addressed is that, what would I do to limit a user that connects, and maybe I have it where every time they create a ledger, I mint, 1,000 tokens or 10,000 tokens. How do I keep track of that is something, to consider. And that's why this token manager could possibly be used for that. If I created a variable, but then like keeping track of the mints or keeping track of even the user. So I certainly could expand on that, and I may it seemed kind of fun doing it. But essentially, that's something that I may go to later. But for now, I don't need, again, we're just doing simple, I'm going to delete some of these comments and stuff and just kind of clean this up. So this is what we're dealing with. Minting supply to user, signing via in rather than dApp token PDA, I'm just going to call it the Mint PDA. Okay. We have a CPI context, so we're signing with a PDA, which is our mint, obviously. So we need the token program. We're going to invoke the MintTo instruction of the token program. Obviously, you have to have authority to mint new supply. But again, our authority is set to the mint right here. Now, one other thing, there's another attribute. I'm going to do freeze authority. Yeah. So you can set it all up right there as it's initialized. And where the mint authority, in this case, is the mint. Okay. And then the signer seeds, well, the signer seeds are changing. So we're going to do, let's change that, and it's going to be the same kind of thing, dApp token mint as bytes. This time, though, the seeds, I need the bump. So I was doing this dApp token manager where I had like a prefix and then say the mint key, and then even like the authority. Like there's things that you could do to, I think it would be kind of neat to make, to do that one day, where you could have like a token manager that may be able to manage over multiple tokens. and they're all like have their own unique PDAs. I'm not sure. But what I need here is I need the bump. So here we have, this is just the seed prefix essentially, and now next I need to pass it the bump, which comes from the context. So you can do this. It's actually another borrowed U8 int array. So to get the bump value that is found here when they create and initialize this account, or the PDA, to derive the PDA, you can dereference the context, and yeah, it shows like what I was doing, but instead, and I'll just context bumps dot get, and then the account name that you're trying to get the bump for is mint. So it's this thing. We gave it a name mint, and then there's this expect bump not found. Yeah, I think something like that would work. And one thing that is different, you could hard code it here. So this is like, amount of supply to mint. You can hard code it, or you can even pass it. So I'm thinking about passing it as a instruction argument, not an account, but just a an argument that you get. So here we have the context, all the accounts that are going to be a part of it, but I could do another instruction data and call it amount. And so this time, from the client, like whenever we mint supply, it would be it could be specified by whatever they want. So we can hard code it or have a little bit more flexibility. And really that's kind of it. One thing that I would like to check is that maybe, like a simple thank you Copilot, check that the amount is more than 0. Expected identifier. Get this out. What am I missing? I'll come back to that. And then down here in our validation struct, I think because we're going to use an amount, and again, I could do instruction data, or another option could be to say hard code it. So say if I'm going to do like a 1,000 tokens at base 10, you could do something like to the number of decimals. That's also something to possibly consider, but for now I'm going to just keep it flexible. And now into our validation struct. This is really cool. So the init-if-needed, this is a feature. Shout out to Bear and Fedoris on this one. This is a feature in Anchor.toml that needs to be specified. So, so yeah, unfortunately, I've gone through all this. Unfortunate for me, but good for you. Anchor.toml, we have sees true, and then where is it? Oh, it's not Anchor. I keep getting it confused. It's actually in my program, my ledger. It's my cargo. Yeah, right here. Anchor lang, and then you have to open it up and specify a feature. So this features equal, and then you're enabling the init-if-needed. Yeah, so that's a really cool thing, because back in here, I don't have, this is to mint token supply and create a token account for the user. So again, a user connects, and it's the first time that they create a ledger. Well, then this init-if-needed will actually go about creating the account. It will have the payer be the connected user, the associated token, the account's mint will be the same mint address, and its authority, being an ATA, we're setting the authority to the user. So again, this is Anchor helping us out, doing it all inside the program. The second time, say the user connects and creates another ledger, but they've already done it once. So they most likely have the ATA, unless they've somehow closed it, but they come in and they create another ledger. This whole part is skipped, because it's going to basically get or create associated token account, and it's going to realize that it exists for the user, and we can move on. So yeah, we want to be able to create the mint. We want to be able to mint supply, right? So one of the things that needs to happen is that our in order to mint supply, we have to make the account mutable. I made a mistake. It was having some issues, like it wouldn't really work, and that was because I didn't make my account mutable. So then the supply field on the mint account is actually getting changed, right, as part of minting more supply. But if you don't make it mutable, then it won't work. It will fail. Constraints wise, this mint is a PDA. So we need to not so much constraints, but we need the bump, and we need the seeds. So just like anytime you are trying to derive, anytime you do something, like if you're trying to have Anchor validate and verify a PDA address, you have to provide it the seeds and the bump. So to do that, well, again, the seeds is just a dApp token mint. I think as bytes. And that should be enough, if I recall. But yeah, so we're kind of getting there, as it you can just kind of see that this becomes just a bit easier to work with, and we don't have to manage like a whole new state account like a dApp token manager. So now that we have this, we can retrieve it. Anchor can retrieve it for us. I don't have anything to do with this anymore, so I'm cleaning that up. And yeah, one of the things, like we have a type signer here for the user do we need it if they already have an ATA? Part of this init-if-needed is, yes, we still need to provide the user, because in the case like Solana, you have to provide all of the accounts up front in the initial, instruction or, transaction. And so it needs to have all of the accounts that it would possibly need. So if a user token account is not created, then we certainly need the user to pay for it, so that it can get created. And yeah, essentially that's it. So this is minting supply for our program specific token, which is, pretty cool, pretty handy, and it's all signed by the program. And I'm going to show one thing that I came across that I thought was kind of cool. So doesn't really make sense in this case, because this particular instruction function is, I'll address this require check later, but this function is pretty small. There's not really a lot happening. It's literally just using the MintTo via CPI. However, this building the CPI context can get a little, there's a lot in there. So one syntax that I noticed, that I came across, that I thought was kind of cool, is instead you can do something like this. So let me get some space, and if I do see top, there you go. Instead you can do something like you can implement, and I think I got this from the Anchor book, where it's like, hey, the CPI context can be a little, messy if you want to compose it, doing it using implementation may make it for cleaner code. So I thought this was kind of neat. So if you do implement and then info, and then obviously we're doing MintDappTokenSupply is our struct that we're working with, then we can expand on this. And one way that you do it is you can create a function that is, say, like you could do MintDappTokenSupply like context or CPI context, just to be really wordy. But then what this does is you can specify, like say, okay, this returns a CPI context, but you have to do these lifetimes in this way. But then you have like the instruction that this is going to do, because we're building the CPI instruction for the MintTo instruction. I would do something like token MintTo, and then with its own info lifetime. So here, this looks really ugly. There's a lot to it, but essentially we have a function that returns the CPI context. So then what this CPI context is, it's just like above. So very similar. So what could I do? Actually, let me split and I'll scroll up here. So this block is the CPI context new with signer. Could be done, and it will work. But another approach is maybe we just do the CPI context below, like this, and then you can use another syntax. So I'm just going to show you because I thought this was kind of cool. So token program, so the exact same thing, token program to account info, yeah, and then using the MintTo instruction, but we have to specify all the accounts. So again, this is like self.mint dot to account info. Yeah. Then 2 is self dot user token. Yep. And then authority. After formatting, this is what you get. Now, this is just the context. I think this only works when you're doing kind of like non-argument context. Okay, so it's not new with signer, it's just new. It's just a standard CPI context. That said, if I wanted to, with this up top in my function, so I'll keep this in the center, but if I go back over here, another option 2, option 1, it doesn't really matter on the naming, but I could have done something like this would then allow me to do something like CTX or still token mint2, the helper, but then I can do ctx.account or accounts MintDappTokenSupply CPI context. Yeah. So I have that, but what I don't have is to sign it, because it's a signer. I do with signer, and then I pass in the seeds. So I pass in the seeds to this, and you have things like which would be the exact same signer seeds. So like you have the dApp token mint and the string, as well as the context bumps get mint. So just a completely different kind of look and syntax. I thought was kind of neat. But I'll flesh this out and then I'll show you when I'm done. Okay, so got it sorted out. And here is what it looks like. I kind of like it. It's clean. You can save the signer seeds, something like this, because that's the real ugly part. But then, yeah, here you are. You're still performing doing the CPI call using the token program to mint new supply. And so we have our context that, again, we build right here. Yeah. And everything aligns. It's exactly the same, except you're just using this, you're implementing some new functionality for this type. So for this particular MintDappTokenSupply type. Yeah, I don't know. It's kind of a nice way to tuck away some of the common stuff that you'll do. And then here in your function handler, the instruction function, you can have it all just right up here, nice and tidy. So again, it is a Mint2. The first thing that you need is a CPI context, which is what this does for us, this whole part. Because it's a CPI context new down below this, we use there's a you can chain the with signer, and that's it. It's basically the CPI context new with signer, and you pass in the seeds. So both work. I've already I'm just gonna leave this cleaned up approach for now as just a optional syntax to look at. So yeah, I found that to be pretty neat. So now we've got it. We've got the validation struct plus its instruction, and again, like that's it. It's really, I've just created one instruction, and I no longer need a new state account to keep track of all this. I can simply mint and initialize the mint directly in the program, along with where was that? Create the dApp token. Yeah. And do something like this. Super, super simple. Clean, simple, fast. I mean, yeah. So I wanted to show that alternative. So next, what I need to do is implement some tests for this to see how we can implement this and add this into the program. So first, I think what I'm going to do is test this on locally using the Solana test validator. I know my main program is deployed on DevNet, but I want to test this out on locally, get that working, and then we can deploy and implement this with our ledgers. So, and which reminds me, for the last video for Vercel, we had to move over our IDLs, and I copied over a lot of my IDLs manually in the last video for the sake of deploying on Vercel. I needed everything to be inside of the app directory. So you have to copy over the IDLs. Well, I did do that manually, but I did find, where was it? I did find this script right here. It's not automatic. I gotta maybe figure out how to do that, but digging around and found this shell script where basically after I do my Anchor build, I run this shell script, and it will take all of my JSON IDL files and dump them into my app lib IDL folder. So yeah, this may be helpful for some of you. So all right, next up we'll do some tests.